Hi, this is Manjunath. Good afternoon to all. Let's start the new chapter, that is trigonometry. Trigonometry. So actually from this what you have to learn means trigonometry is the relationship between the angles and sides of the right angle triangle. In this right angle triangle is very important. Then actually it is derived from the words tri means three, this one, and gon means side, and metron means measure. So the meaning of this trigonometry is nothing but it is a three-side measure. So in the right angle triangle we have three sides, and the right angle triangle we have the formula that one hypotenuse is equal to square is equal to adjacent square plus opposite square. This is the formula of the hypotenuse square is equal to adjacent plus opposite square. If you take example, in your textbook they given as the first example. Suppose the students of school are visiting the minar. If a student sitting at the top of the minar, then a right angle triangle is imagined, because you see one boy standing, one student is standing there, and he is seeing at the top of the Qutb Minar. There we can find it is imagined like right angle triangle, because the height of the Qutb Minar is taken as uh, perpendicular, and downside there is the surface is the width and opposite is the hypotenuse. Then same like that. One more example is there. So suppose a girl is sitting on the balcony of her house located on the bank of the river. So located on the bank of river, she is looking down at a flower pot placed on a stair of temple situated nearby on the bank of the river. If you see the diagram, so she is sitting at the top. She is seeing the flower at the temple, and the from this we can imagine that one right angle triangle. Then if you know the height at which the person is sitting, if you know this height this one, then you can find the width of the river. Like that, third example, hot air balloon is flying in the air. So a girl happens to spot the balloon in the sky. She is seeing that place where it is flying. Then she calls her mother to tell about it. Her mother rushes out of the house to look at the balloon. Now when the girl had spotted the balloon, initially it was at point A. It is point A. Then after, when both mother and daughter came out to see it, it had already traveled. It has traveled from this to this. So up to point B, can you find the altitude of B from the ground? This is this height we can find. So from three all examples, one thing we can conclude means, that is right angle triangle is based on this trigonometry. So meaning is tri means three, gon means side, and metron means measure. So three sides measure, but it is always a right angle triangle. For right angle triangle only we can use trigonometry. For other than right angle triangle we can't use the trigonometry ratios. So from that three examples also we can find the distance or heights can be found using the mathematical techniques, that is called trigonometry. So the trigonometry is the branch of mathematics which deals with the study of sides and angles of right angle triangle. So in this there are 6 trigonometric ratios. Trigonometric ratios means trigonometric ratios. So trigonometric ratio is the sum of the sides of the triangle. If you take this one, A, B, and C, this is the angle at B is the right angle triangle. So ABC, some ratios of the sides of the right angle triangle with respect to acute angles. Why these two are acute angles means, Why these two are acute angles? It is right angle triangle means this will be 90. So the sum of the angle of the triangle is 180. Total it will be 180. So remaining is 90 is there. So these two at side will get the 90. So sum of these two angles is 90 means these two always will be acute angle only. So angle A is acute angle and angle C is acute angle and angle B is the right angle triangle. The total of the triangle will be 180. In that 90 is the B angle and remaining that two sides of the triangle is A and C of the angle, that is 90. Sum of the A and C are 90. So they are to their angles will be always acute angle. Then there are six trigonometric ratios. We have to remember that one, which are helpful for the whole lesson, that is trigonometry. First one is sine, second one is cosine, next tangent, cosecant, then secant, last one is cotangent. So if you take example, this one is A, B and C. This is right angle triangle. So if I want to find the sine of cosine, tangent, cosecant, secant and cotangent, there are six formulas. That is, if you take this is called hypotenuse and this is opposite, and here take A only, opposite and adjacent. So sine of A, if you find this one sine of A, it will be opposite by hypotenuse. Opposite by, formula is opposite by hypotenuse. Similarly, for cosine, it is adjacent by hypotenuse. For tangent, it is opposite by adjacent. So for these three, remaining these three, cosecant is the reverse of sine. So reverse of sine means it is opposite by hypotenuse, then it will be hypotenuse by opposite. Similarly, for the secant angle, it is the reverse of cosine. So cosine is adjacent by hypotenuse, so secant will be hypotenuse by adjacent. Then last is cotangent. Tangent is opposite by adjacent. Therefore, the cotangent will be adjacent by opposite. So if you take this one as the right angle triangle ABC, in that B is the angle at 90 degrees. So remaining these two will be 90 degree. Some of the these two angles will be 90 degree. They are acute angles only. Then there are six trigonometric ratios which are helpful for this one. That is sine, cosine, tangent, cosecant, secant and cotangent. If you take this one as the A angle, so sine A is equal to, for all it is A only, for angle A. So sine A is equal to opposite by hypotenuse. This is hypotenuse, this is adjacent, this is opposite. So sine A is equal to opposite by hypotenuse, and cosine of A is equal to adjacent by hypotenuse. Similarly, for tangent it is opposite by adjacent. Then cosecant is reverse of sine. Sine reverse means hypotenuse by opposite. Like that, secant, it is the reverse of cosine. It will be hypotenuse by adjacent. Then lastly, cotangent. It is the reverse of tangent. Tan A is opposite by adjacent. So cot A will be adjacent by opposite. So these six are the main formulas for this right angle triangle of that doing the trigonometry. So we can write tangent, tan, if you take tan A, similarly for this triangle only, tan A is equal to, we written opposite by adjacent. So if you take this one, sine is opposite by hypotenuse, and adjacent by hypotenuse. If you divide hypotenuse to both sides of this tan A, it will become opposite by hypotenuse and adjacent by hypotenuse. The opposite by hypotenuse is nothing but sine A, Sin A, and adjacent by hypotenuse is nothing but cosine, cos A, cos A. So from this we can derive that one. Tan A is nothing but sin A by cos A. How means it is opposite by adjacent. Opposite by adjacent. If we take divided by hypotenuse both side, opposite by hypotenuse and adjacent by hypotenuse. So remains the again opposite by adjacent. So opposite by hypotenuse separately if you take means it is sin A, sin A. Adjacent by hypotenuse if you take that will be cos A. So the formula for tan A will become sin A or by cos A. It is nothing but opposite by adjacent. The total we can call it as sin A by cos A. So cot A is reverse of tan A. So cot A will become cot A. This is reverse of this one. So it will become cos A by sin A, because cos is adjacent by hypotenuse is there, adjacent by hypotenuse, and sin is opposite by hypotenuse. If you divide this one same, it will remain adjacent by opposite. Where is the adjacent by opposite? It is cotangent. So adjacent by opposite is nothing but cot A. These are the 6 trigonometric ratios. The next one, after this, one method is there. The value of the trigonometric ratios do not vary the length of the sides of the triangle when the angle remains the same. It is values of the trigonometric ratios of an angle do not vary with the lengths of the sides of the triangle if the angle remains the same. So we have to prove that one. So for this proof, one example they have given. So if you take this is A, this is B, and this is C. If we extend this one, I am taking here Q and M on the upper hypotenuse AC. So perpendicular to AB, that is P. This one M. I am extending this one. Here also extending. So if you see the diagram, this one. So if you take the right angle triangle ABC, in that P is a point on the hypotenuse AC and M is the PM is the perpendicular to the AB, and then one if you extend the AC to the Q and AB to the N, that also Qn is perpendicular to the AB. So from this one we have to prove that the value of the trigonometric ratios of the similar triangles is do not vary with the length of the sides of the triangle if the angle remains the same. So as you learn that in the this also A is there, ABC for ABC also it is angles A, for PAM is also for it is A, and for QAN also it is angle A. So angle criteria what we can write means, if angle is the same is there means we can write that one corresponding sides of the triangle are proportional. When it is this one, when it is similar, the triangles when they are similar. So if you take this one as CAB and PAM are similar triangles, triangles then corresponding sides of the triangle are proportional. So what is the condition means, if you take AM divided by corresponding sides, AM is the PM value and ABC is the AB. So AB is equal to this one opposite or hypotenuse you take. AP is the hypotenuse, so AP divided by, so on the same side corresponding side means AC is equal to PM by CB or BC. PM by, so you can write this one as sine. If you take sine, this one sine A, you can write sine A is formula is opposite by hypotenuse. So opposite is nothing but this one, opposite is BC divided by hypotenuse AC. So is BC by AC. So here also see this one, you can write this one as AP by this one, see AP by PM is equal to AC by BC. You can write this also, no, AP by PM or AC by BC. Then AP by PM is this one AP by, this is PM and this one AM. So if you take sin A will become this BC by AC. If you take for the same that also sin A, it is AP by PM. So AP by PM is equal to AC by BC. So if you take sin A is nothing but BC by AC for the triangle ABC. If you take that one only for triangle PAM, it will become sin A is equal to this one opposite. This is opposite PM divided by PA by PA. So sin A is equal to BC by AC for the triangle ABC. For sin A only for the triangle PAM, it is PM by PA. Because these two are similar triangles, so it is PM by PA is equal to AC by AC. PM by PA is equal to AC by BC. If you take cos A is adjacent by hypotenuse. So AB by hypotenuse is AC. So for that triangle PAM, it will be adjacent means AM. Hypotenuse is nothing but AP. So AP. So cos A is equal to AB by AC, and for PAM triangle AM by AP. Like that, you can take here also tan A is equal to if you take tan A is opposite by adjacent. So BC by AC. So see here tan A is equal to opposite nothing but here see this one. Actually I was recording, but it was stopped there due to the low storage space. Then I will continue again this only. Tan A is equal to BC by AB. Tan A is BC divided by AB is equal to PM by AM. So PM by AM, this proves that one, the value of the values of the trigonometric ratios of an angle do not vary with the length of the triangles if the angle remains the same. So we are getting same only. For this one diagram, it was there. A, B, C, P, Q, here M, and this one N. So if you see this one, tan A is equal to BC by AB. So BC is BC by AB. It is opposite by adjacent. For that also we have proved that one PM by AM. So PM by AM is also a opposite by adjacent angle of the triangle PAM. So it proves that one the value of the any trigonometric ratios of an angle, if the corresponding sides of a triangle are proportional, that is similar triangles, then it is the do not vary with the length of the sides of the triangle. If you take the PAM also same and QAN, if you take with the respect to ABC, then that proportion will be same only. After that, in that example, one example they given, what is means ABC is there, angle B is at 90 degree, and A is the sine angle. So and C another angle. This is 90, and these sum of the two angles is 90 degree. Then they given in that AC square is equal to AB square plus BC square. Why means it is Pythagoras theorem. By the help of Pythagoras theorem, you can write AC square is equal to AB square plus BC square. They given sin A is equal to 1 by 3. 1 by 3 means you can take variable. So 1k or 3k. So it will be k by 3k. If you know these two sides, then you can find the AC. How mean AB means it is they given AC as 3k and BC as k. So if you take the squares of these two, then you subtract this one, then you will get the sin A value is 1 by 3. Then you can find the for this also cos A, tan A, like that. We can find other trigonometric ratios by the help of this, because if we know the trigonometric ratio of one of the side, one of the triangle, then another side will be taken by the help of Pythagoras theorem. Then we can calculate the other trigonometric ratios. So in that AB we will find out. After that we can put the cos A and tan A. Like that, in the first example, they given ABC, B is an angle at 90 and AC. Then they given AB as 3k, BC as 4k. So you can take they given as tan A. So tan A is equal to 4 by 3. This will opposite by adjacent formula. Then opposite by adjacent, it will be 4k by 3k. Then AC square is equal to AB square plus BC square. Why? It is the hypotenuse is equal to adjacent plus perpendicular square. Then if you take BC by AB, then you will get the value AC. If you know the three values, you can write the cos A, tan A, like that, cos A, sin A with the other trigonometric ratios. They only we have to find the three sides. When you know the all three sides, you will get the trigonometric ratios of all the six trigonometric ratios. Then so from this they will find AC. AC will be 5k. So if you write the AC is equal to 5k, if you take example only sin A. Sin A is nothing but opposite pi. For this only, if you take sin A, after that it will become 5k. So sin A is nothing formula opposite by hypotenuse. So opposite here is BC, hypotenuse is AC. It will become 3 by 5. 3k by 5k means is nothing but 3 by 5. So the answer will be 3 by 5 for the cos sin A opposite by hypotenuse. 4 by opposite by hypotenuse. 4 by 5. This is 4. 4k by 5k. 4 by 5. So 4 by 5 it is opposite by hypotenuse is nothing but sin A. So like that you can find tan as they given BC by AB, that is 4 opposite by adjacent 4k by 3k. It is 4 by 3. So if you know the all three sides, you can write the trigonometric ratios for the remaining also. Like that, they given example 2. Example 2. In example 2, they given if ABC, this is ABC. This is ABC, ABC, and another one triangle PQR, PQR. So right angle triangle. This is also right angle triangle. Then this is angle they given B, and this is angle Q. That if angle B and angle Q are acute angles, this will be acute angle only, because it is 90 degree means these two will be acute angles only. So this is also same like this only triangle. So PQR is Q will be acute angle. Then they given sin B is equal to sin Q. Sin B is equal to sin Q. This is the given this one. So what we have to prove? We have to prove that angle B is equal to angle Q. From how we can prove this? I'll show you that one. First step for this one, sin B is equal to sin Q. So sin B means it sin B. Sin formula what is there? Opposite by hypotenuse. So A is there, sin B is there. So B means opposite is this AC divided by hypotenuse is AB. So AC by AB. That like sin Q you take. Sin Q means this one. Sin Q is equal to opposite by hypotenuse. This is PR divided by PQ. So what they given condition? Sin B is equal to sin Q. So sin B we can write AC by AB. AC by AB. That will be equal to PR by PQ. So we can write this like this also. If you take AC by PR or AB by PQ, same no, because PR will take this side, AB this side. So AC by PR, AB by PQ. So AC means this one. Then PR is this one. Same no, corresponding AC PR. Then AB this one hypotenuse. Then this PQ this hypotenuse. So if you take this one as K, if you take say this one as K, where K is a positive number, K is positive number, K is a positive number. Then so you have to prove that angle B is equal to angle Q means, then you have to prove that these two triangles are similar. Then only the angle B will equal to angle Q. So for that, if you take remaining is BC, we are not this side. So BC by QR. This value you have to find out. So BC what we can write means BC is this one. So you can write root of hypotenuse square AB square minus hypotenuse AB square is equal to AC square plus BC square. Then BC you have to find root of AB square minus AC square. Like this also QR we can write as QR PQ square minus PR square. So we can write BC is equal to root of AB square minus A square. Why means we know the formula, that is AC square is equal to AB square plus BC square. This is the Pythagoras theorem. From that I find out the BC. This will become this side AC minus AB square. AB square is equal to BC square plus AC square. Then AB square is equal to AC square plus BC square. Then from this one you can find by the value of BC, that is root of AB square minus AC square. Similarly for this also you can find the value, that is for QR is equal to PQ square minus PR square. Then we take it as K. So root of AB square you can write as AB square is that, here is that AB square. If you take AB by PQ is equal to K, then if you take square on both sides, square, what will become? AB square into divided by PQ square equal to K square. Then we want AB. So AB means this will go this side. So it will become K square PQ square. Similarly for AC you can take these two. This is also K. AC by PR is equal to K. If you square on this side, that will AC square divided by PR square is equal to K square. Again AC square you can write as K square PR square. K square PR square. Downside is root of PQ square minus PR square. Then if you take this one K square outside, it will become K. Remaining is root of PQ square minus PR square, and remaining downside also PQ square minus PR square. So it will be this one and this one get answer. The remaining will be say K. Then we prove that BC by QR is equal to also K, AC by PR also K, AB by PQ is equal to K. Then what we conclude that one is AC by PR is equal to AB by PQ is equal to BC by QR. So we have proved this corresponding angles are proportional. When the corresponding angles are proportional, then these two triangles will be similar. If it's similar means this angle B is equal to angle Q. This only you have to prove that. From the help of this BC by QR, you have taken the Pythagoras theorem applied for both sides. Then you taken that one value AC by PR or AB by PQ as K. Then K, where K is a positive number. Then you simplify this one by the help of this one. Then you got the K. So this is also K. So we can write AC by PR, PR by AC by PR, AB by BQ is equal to BC by KR. Then these two angles, these two triangles are similar. But that third problem. Third problem is the one. Consider triangle ACB. In that right angle triangle is C. Same diagram only, ACB. Then in that AB they given as AB 29. So this value they given as 29 units. Then BC, this one BC 21 units. Then they told you to find out the values of cos square theta plus sin square theta, cos square theta minus sin square theta. Before that I will tell cos square theta also. That one, sin square A is written as sin A whole square. So if we write sin A into sin A, it will become sin square A. So sin A is equal to sin A whole square is nothing but sin square A. If you take cos square A like that, this will be cos A whole square. So cos A whole square is nothing but cos square A, because cos A into cos A is cos square A and sin A into sin A is sin square A. Then they given what we have to find, cos square theta plus sin square theta. This is theta they given. This angle they given as theta. Then you have to find the first one, cos square theta plus sin square theta. Second one, cos square theta minus sin square theta. So they given two sides value. So this is 21. So first and foremost you have to do the remaining side of the triangle, that is value. So 29 is there, 21 is there. So if you take hypotenuse square, that will be AB square is equal to BC square plus AC square. So here BC is nothing but 21 square and AC square is 29 square. This will be 21 square is 441. Okay, they given AC square they not given. So this will be AC square. This one AB square they given as 29. This is 29 square. So if you do the 29 square will be 841 is equal to 21 square is 441 plus AC square. That will be AC square is equal to 841 minus 441. It will be 4 minus 4 is 0, 1 minus 1 is 0, 8 minus 4 is 4. So AC will be root of 400. Root of 400 is nothing but 20. So you got this value was 20. So 21 square plus 20 square is we are getting the value of 29 square, that is 841. So you got the AC value. Then they ask you to cos square theta, this one cos theta. First you find out cos theta. Cos theta is equal to, formula is adjacent by hypotenuse, that is BC divided by AB. So BC is here what? BC is 21 square, that is 441 divided by AB. So AB is nothing but 29. This is 29. This is 21. So they given this is cos theta. Cos theta is equal to adjacent by hypotenuse, so 21 by 29. But they given cos square theta. So cos square theta means squaring on both sides. So it will become 21 square, that is 441 divided by 29 square, 841. This is 21 square 441 and 29 square 841. This is the cos square theta value. Then for sin square theta, if you take sin theta is equal to this only, sin theta is equal to opposite by opposite, that is 20 by 29. So square of that only means 20 square is 400 divided by 29 square is 841. So 400 by 841. So you got the value. This is 441 by 841. This is 400 by 814. The what for the first condition what they given? Cos square theta plus sin square theta. So cos square theta is what? 441 divided by 841 plus sin square theta. Sin square theta is this one. This is sin theta. This is sin square theta. So sin square theta is 400 by 841. So it will be 441. It is nothing but 841 divided by 841. So it will be 1. So for this one the answer is 1 for the cos square theta plus sin square theta. Similarly for this one, cos square theta is what? 441 divided by 841 minus sin square theta. Sin square theta is this one, 400 divided by 841. So 441 minus 400 is 41 divided by 841. So the value of these two will be cos square theta plus sin square theta, and cos square theta minus sin square theta, it got 400 by 841. Then cos square theta minus sin square theta, it will be 14 by 841. Then this one 441 divided by 841 plus 400 by 841, it will be 841 by 841. It will be 1. So cos square theta plus sin square theta is equal to 1, and cos square theta minus sin square theta is 41 by 841. So how we find means, first we have to find cos theta, then you can squaring on both sides, then sin theta similarly squaring on both sides. Similarly for example 4, in a right triangle ABC, this is ABC, wait, this is ABC, A, B, C, and right angle triangle is at B. Then tan A is equal to 1. They given tan A is equal to 1. This is, so we have to prove that 2 sin A into cos A is equal to 1. 2 sin A into cos A is equal to 1. So they given this one given. So we have to find out the value of 2 sin A cos A is equal to 1. So tan A means what? We are taking this one and they given this tan A means opposite by adjacent. For this opposite it will be BC. Opposite will be BC divided by adjacent means this one AB. If we take this one as C angle, then it will be adjacent will be BC. If we take this one, the adjacent will be AB. So the same side will be adjacent, and opposite of that will be opposite side, that is BC. So BC by opposite is BC. BC by AB. Adjacent is AB. Then we can write this one tan A is equal to 1. So tan A is equal to 1. So it will become BC is equal to AB. So you can take value is BC is equal to AB as K. So it is a positive number. So K will be positive number. So find out this one hypotenuse square. So that one AC square is equal to AB square plus BC square. So AB square plus BC square. AB is K only, K square. This is also BC is also K, so K square. It will become 2K square. So if you take root of this one, it will become K outside, but root 2 is root 2. So K root 2. So we got the AC value as k root 2. Then they told to 2 sin A cos A. So you can write sin A as sin A. If you take sin A, it will be opposite by hypotenuse. So BC by AC. BC by AC. So BC is what there? 1. So K. BC is nothing but K divided by AC. AC you find out that one K root 2. K root 2. So this will be 1 by root 2. Why means K and will cancel. Like that same as cos A. Cos A is equal to adjacent by hypotenuse. Adjacent is AB. Hypotenuse is AC. So for this AB is equal to K divided by AC is again K root 2. K root 2. This is also 1 by root 2. Why means K and K will get answer. So if you take the value of 2 sin A cos A, it will be 2 into 1 by root 2 into 1 by root 2. 2 into, they given 2, sin A is nothing but 1 by root 2, then cos A is nothing but 1 by root 2. So 1 by root 2 into 1 by root 2. Root 2 into root 2 will become 2. So 2 divided by 2 is 1. So it is proved that 2 sin A cos A is equal to 1 when they given tan A is equal to 1. Tan A means opposite by tan A means this one A opposite by hypotenuse, opposite by adjacent. Like that sin A means opposite by hypotenuse and cos A means adjacent by hypotenuse. That is AB by AC. Then we know first we find the AC value and we have taken that value as a K. So K means BC is equal to AB is equal to K. That will be K square plus K square. Then you get the value of AC. Then from these three sides we can find out that sin A cos A. Then 2 sin A cos A is nothing but 2 into 1 by root 2 and 1 by root 2, that is 2 by 2 is 1 because root 2 into root 2 is 2. Example 5. In triangle OPQ, right angle let P. So right angle this one P. OPQ. Okay. Then the given OP as 7 cm. This is 7 cm. And OQ minus PQ. OQ minus PQ. The given as 1. OQ minus PQ is equal to 1. Determine the values of sin Q and cos Q. Okay. So first for this one, what we have to find means we know this side, but we don't know this side values. So they given the hint that OQ minus PQ is equal to 1. So what we can write? OQ is equal to 1 plus PQ. You can write now OQ is equal to this side comes means 1 plus PQ. So this is hypotenuse square. So OQ square is equal to PQ square plus OP square. So OQ square what it is then 1 plus PQ. So 1 plus PQ whole square is equal to PQ square plus OP square. From this one, if you take A plus B whole square, it will become 1 square plus PQ square plus 2PQ. 2PQ is equal to PQ square plus OP square. So this one PQ square and this PQ square will get cancelled. Remaining is 1 plus 2PQ is equal to OP square. So why I have done like this means if you take OQ square is hypotenuse, then PQ square plus OP square. We know the value of this one, but we don't know this value. So we know the difference of these two. Then you can substitute this one OQ as 1 plus PQ. Then you get the 1 plus PQ square plus 2PQ is equal to PQ square plus OP square. Then these two get cancelled. 1 plus 2PQ is equal to OP square. OP square they given 7 cm. So 49. 1 plus 2PQ. So 2PQ is equal to this will go 1 that side is 48. This will imply that PQ is equal to 24 centimeter. This is 24. PQ is 24 means OQ means 1 plus 24. This will be 25. If you know all the three sides, you can write the values for the any trigonometric ratios. Then the given find the value of sin Q and cos Q. Sin Q and cos Q. So sin Q is nothing but here Q this one another given sin Q. So sin formula is opposite by hypotenuse. That is 7 by 25. 7 by 25 because this one opposite is 7 and hypotenuse is 25. For cos cube, adjacent by hypotenuse. This one adjacent divided by hypotenuse. That is PQ by OQ. So 24 by 25. 24 by 25. So mainly we have to remember that three formulas, that is sin A, cos A and tan A. In that the reverse of 3 it will be cosecant, secant and the cot. So we get the tan reverse is cot. So like that when they give one value you have to find out the other when they give the one trigonometric ratio you have to find the other remaining third side of the angle, then you will get the remaining trigonometric ratios as how you want. So today for this this much is okay. So we have to add the formulas, that one sin, cos, tan and cosecant, secant and cot. So if you know that first three, we can reversely that three will be you can write. So you have to remember that that three determinant ratios. Then only that we have to solve the problems. So today for this enough. So thank you.